All right, this video today is just for the calculator portion of the review. And I made this announcement in class, but I realized that I've sort of inverted the table of information that I gave you. This says a pediatrician wants to find a model related a child's height to their head circumference. And I guess you could put these in any order, but the way that I have this is like H of C. It's that H is the output and C is the input. Like based on your head circumference, we can predict what height you'll be, that type of thing. So when I enter this into my calculator, and again, we talked about this in class, but in case you were absent, change the order of these. Put the Y values, the outputs, the heights into L2 and the head circumference into L1. And if you forget how to do that, you go to Stat, Edit, start typing in the head circumferences here and the heights here. All right, so part A says that we want to use a graphing calculator to find a linear model to fit the data. So that means linear regression. And remember, just like on the quiz, use the correct variables established in the problem. So I'm not going to say Y and X, I'm going to use H and C. All right, so how do I get the regression model again? So once you have everything entered in, you go to Stat, Edit, you go to Stat, Calc, and then I choose option 8, linear regression. Option 4 is also linear regression. You can see they just switch the order of information they give you. So I choose 8. Should say L1 and L2. Store regression equation. We want this in Y1, so the shortcut is alpha trace Y1. And then ask it to calculate. All right, so for this, again, instead of Y equals, I'm going to say H equals, the height equals. So it's negative 10.527145536. Do not round these numbers. Plus 2.149737303. And instead of X, I'm going to write what the input is, which was C. Now, again, on our test, I do not have the order switched. So whatever is the input is on top, whatever is the output is on the bottom. I think I actually even put the words input, output, so it was clear. Because sometimes you could switch, this order could be switched either way. You could predict head circumference based on height. Okay, anyway, so now looking at this problem, so this is my model. Fill in the blanks with context. So H of C models what as a function of what? So it always models the output as a function of the input. So your job is to put the context in. So output is the height as a function of the input, which is head circumference. All right, so the thing to study is that you'll be filling in the same blanks. The model is of the output. It's a function or it's based on the input. Interpret the slope found in part A. So the slope is the number that's being multiplied by the input. You can round this to 3 places if you'd like, or you can use the whole decimal or a longer version of it. But the interpretation for this is on average, because this isn't the true slope, this is not perfectly linear data. On average, the output, the height, increases by, I'm going to round, this 149 would round up to 150, so 2.150 inches per inch, that's weird, in head circumference. I guess you could say inches per inch. That's kind of weird. But the height increases. You want to say what the input is. It increases by 2.15 inches, or you could say like for every 1 inch increase in the head circumference. Use the model from part A to predict the head circumference of a child who is 3 feet tall. So be careful here. 3 feet, but we're putting everything is measured in inches. So really, we don't want to find H of 3. We want to find H of 36 because 3 feet is 36 inches. All right, so this is why I stored my equation into Y1, so I don't have to type all these decimals out. I can just say Okay, calculator, please find y1 of 36, and it does it for me. So round this answer to 3 places. It's 66.863, about equal to 66.863 inches is the label on height. That's my answer there. Always label your answers. You're prompted to do that on the test. It'll say include units in your answer. Okay, the other type of calculator problem that we have is a composition. So there are always a lot of words in here, just like on our AP test, but you're kind of picking out the important information. So there's a fun little physics story up here. Kinetic energy is directly proportional to the mass of an object and to the square of its velocity. So here's the original relationship. I've checked this with Ms. Polivka to confirm this is correct. So K is measured in joules, M is the mass of an object, which will be like some constant, and V is measured in meters per second. So suppose an object has a mass of 3 kilograms. Okay, so they've put the 3 in the equation for you, 3 over 2, and it's moving for 10 seconds. Then the object's kinetic energy could be modeled as this. So did you need all of this information up here? No, maybe for labels, yeah. But otherwise, no. So here's our original function, K of V. And suppose the object's velocity could be modeled by a function of time. So V of t is 4t minus 1. And we have this little domain here where V is measured in meters per second and t is in seconds. So just like we had on our quiz and in our notes and in our review for the last quiz, write this composition function, include a domain, and interpret the meaning. Okay, so K of, instead of V of t, I'm going to put in 4t minus 1. That means you're plugging 4t minus 1 in for this little v in K's original function. So 3 over 2 times 4t minus 1 squared. So write the model, done. With the domain is given to you. The input is lowercase t. The domain for lowercase t is between 0 and 10. And then interpret the meaning and context. So remember, you can kind of use back here, this is basically your script for interpreting whatever a model is. So K models the output as a function of the input, or as so I can say this is a model of what's K, kinetic energy, as a function of or based on what's T, time. That's it. That's all you have to say. It does not have to be a big, long explanation. This is just saying it's a model of the output based on the input. All right. And then part B, we need to find the object's kinetic energy at 4. So they're asking us to find K of 4 times 4 minus 1. Now, it is not hard to just plug that into your calculator exactly as I've written it here onto the home screen. But I do want to show you that I want to remind you, I should say, that you can put this into y equals. So 3 over 2 times parentheses 4x minus 1 squared. So here's the model, right? And then I can go back to my home screen and say, all right, now I don't want y1 of 36. Now I want y1 of 4. I get 337.5, which is the same thing I would get if I just did it like this. Same thing. So however you want to do that one. This option is nice when the function is ugly. So this equals 337.5. And then what's the label on K? The label on K is given in the problem. If you look back up here, you have to read through this a little bit. K is kinetic energy. It's measured in joules. All right, now I do need my calculator for the next part. Again, maybe not necessarily. You probably could solve this algebraically. But what you're saying is, when is 3 over 2 times 4t minus 1 squared, when is that equal to 1,000? I could do the algebra. Multiply by 2/3, square root, add 1, divide by 4, done. But why don't I just do this? Put 1,000 down here. Because what if I mess up algebraically? Put 1,000 down here. You're given a domain for your window, set at 0 to 10. zoom fit. There's the point of intersection. So let the calculator do the work for you. Second, trace, intersect, enter, enter, enter. So I'm getting when t is about 6.705 is what this would round to. You do have to round correctly to 3-place accuracy for the AP exam. So if you say that's 6.704 and that was just a 1 point all or nothing part of that answer, then you don't get credit for it. So be careful. And then also label your answer. T is measured in seconds. All right, so that's the calculator part. This is everything you need to know. You need to be able to do a linear regression. You need to be able to interpret slope, plug a number into your linear regression and get an answer. You need to be able to write a composition, interpret that composition, plug a number into the equation, and then set the equation equal to a number and solve it by graphing. All right. The calculator stuff does not go away. We do this all year. So don't just hope that, like, okay, I don't know it now, and then this test will pass and I'm over. You have to know the calculator stuff to be able to do the AP test this year and next year in calculus. So come see me if you're having any trouble with your calculator. All right. That's it for this video.